All right, so now we're moving on to the last section of chapter 5, and that's section E, and it's going to be multiplications involving radicals. All right, so we have already done multiplications with radicals, so this section really should be very quick and very easy. We're now just going to discuss and go over one particular type of how we will present the multiplication now. So before, we did our multiplication by saying square root of 6 times the square root of 2. We looked and said, are our indices the same? Yes. So then we can multiply what was on the inside. And when we get the square root of 12, and then we'd have to simplify if we could, and this would then reduce to 2 times the square root of 3. All right, this is what we did in the past. Now what we're going to do is we're going to have to distribute a radical in. So we're going to have to distribute, multiply, and then simplify radicals. So we already learned how to distribute. If I gave you 2 times x plus 4, we already did this earlier in the year. We know that when we have this written next to the parentheses, it means it needs to multiply, and we know it means to multiply everything. So this becomes 2 times x, or 2x, times 2 plus 4, or 2 times a positive 4, so it becomes plus 8. So we've already learned how to distribute, and I know you already know how to distribute. So now all it's going to be is, instead of it being 2 and x plus 4, would be the square root of 2 times the square root of 3 plus the square root of 5. All right, and we are just going to have to distribute these in. So it's the exact same thought process, the exact same everything that we did before, but now we're combining it with section B, in which we learn how to multiply radicals. So as I was just saying, the rules for expanding expressions containing radicals are identical to those for ordinary algebra, meaning if we had a times b plus c, we can distribute this a in and get a times b plus a times c, right? Nothing changes. It's the exact same thought process, the exact same rules. All right, let's go ahead and do a couple examples real quick. All right, the first one we're going to do is letter A, and this says 2 times, in parentheses, 2 plus the square root of 3. So as we know, we can't combine 2 plus the square root of 3 because 2 does not have the square root of 3, so we can't actually add those. We just did that last section. So now what we need to do is we need to distribute this 2, and we need to still simplify as much as we can. So it becomes 2 times 2 plus 2 times the square root of 3. Well, I know 2 times 2 is 4, and whenever I'm multiplying a whole number with a radical, it simply just gets written out front, so 2 times the square root of 3. And this is your final answer. Right? You do not have to show me this step here, but I'm just showing you what we're actually multiplying. Right? And then for B, we had the square root of 2 times 5 minus 2 times the square root of 2. So before we can distribute this in, since I see I have multiple radicals, I need to identify, are our indices the same? Because if they weren't, we would probably just keep it exactly like it is now, since we can't actually simplify it anymore. But since they both have an index of 2, they're both square roots, I can multiply them. So that means I'm going to distribute this in to both. So it becomes 5 times the square root of 2 minus 2 times the square root of 2 times the square root of 2. Well, whenever I have a whole number times a radical, it just becomes 5 times the square root of 2 minus, since these indices are the same, I can multiply what's on the inside, so it's the square root of 4. And now, if I can simplify, I must simplify. So 5 times the square root of 2 minus, and the square root of 4 we know is equal to 2. So it becomes 5 times the square root of 2 minus 4. All right, so you could skip some of these steps here. You could go straight from this step to this step, and you could go straight from here to this third step as well. You don't necessarily have to show me that you're multiplying them, because I can identify what you actually multiplied based on your work. But I don't want to see you just go straight to the answer, all right? Especially because this one has a couple steps involved. I want to see you do either this step here, or one of these steps as you're doing it, all right? But nothing changes. We're simply just distributing the square root in, all right? And then these are the last 2 problems that we're going to go through. Same thing, we're distributing. I notice here that they had the same index, so that means I can actually distribute this, so I'm going to distribute it in. I get 2 times negative 1, so that will give me negative 2 times the square root of 3. And then I know the square root of 3 times the square root of 3, this distribution here gives me the square root of 9. And then I can simplify. Negative 2 times the square root of 3 plus 3. And then this is your final answer. We can't combine the negative 2 and 3 because they're not like terms. This one has a square root of 3 and this one does not. All right, so That is it for A. Now for B, same thing. I notice that there's 3 radicals. So I look and see, are all of my indices the same? Yes, they're all square roots. So I'm going to distribute this in. So a negative times a positive will give me a negative, and square root of 2 times square root of 2 is square root of 4. Negative times a negative gives me positive. Square root of 2 times square root of 3 gives me square root of 6. Simplify anything that I can. So this will then give me negative. Square root of 4 is 2, so it's negative 2 plus the square root of 6. Right? And then there's nothing else that we can do from here. All right, that is all I'm going to do for this video, just to keep it kind of short. The questions will get harder than this. It won't be as basic as this, but it's all the same thought process and all the same concept. We've already simplified a bunch of radicals, so regardless of how big this number gets, you should know how to do that. And we've already learned how to multiply radicals, and we've multiplied very large numbers as well, so it really isn't anything new. So this is something that you guys all should be able to do. And now if we go to multiply these and they simplify to give me the same radical, you must add them if you can. All right, so that is it for this video.